welcome back. It's chapter 6 and we're doing extension number 2 today, where we're going to talk about not just slope, but slopes of particular types of lines, parallel lines and perpendicular lines. And if I asked you, what does parallel mean? I hope you can give me some sort of nice definition for that. Yeah, I know you can draw the picture, and a lot of times they say they're railroad tracks. Yeah, I get that. But really it's two lines that never meet. Or you can say they do not intersect. So I want us to look, okay, I want to plot these lines, and I want you to calculate the slope of each of these lines. And then we're going to hopefully find out something about slopes of parallel lines. Okay, so A is the coordinate 1, 1. There's A. And then B is 5, 1. Okay, and I want you to find the slope of this line. Remember, slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. That's right. You could have told me this was 0 anyways because it was a horizontal line. I get it. Okay. CD, that's 7, 3. And then 10, 3. They don't necessarily need to be the same length, right? Doesn't matter, but what you'll see here also is that the slope is equal to 0. What do we know then? Interesting. Flat lines, 0 slopes. Okay. How about these two here, E and F? So 0, negative 2. F is 6, 1. Connect like this. And then the slope here, well, slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, 1/2. Notice you can see this 1, 2, 3, 4, 5, 6, running 6, going up 3, half. And then GH, G is 1, 2, that's here. H is 5, 4, up here. Notice once again, if I were to use the slope formula, won't sing this time, you get 2 over 4, but that's also equal to 1/2. And I hope you can visualize that these lines in blue are parallel, and of course these lines in red are parallel. So what do you find about parallel lines and their slopes? If you said they're the same, you are correct. So the slopes of parallel lines are the same. Ding, 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 ding. Same. Good. Parallel lines, slopes the same. How about perpendicular then? What happens with perpendicular lines? That's when they meet at a right angle. So yeah, the two lines meet, or if you don't want to use the word meet, we can say intersect at a 90-degree right angle. Okay. Now to visualize this one, I'm going to ask you to plot this line AB, where A is 0, 0. So put a dot there, and then B is 4, 3. We'll put a dot right here. There is AB. And if I ask you for the slope of AB, that'd be 3 minus 0 over 4 minus 0. That is 3/4. Now rotate the point B 90 degrees clockwise. Okay, so if I rotate it clockwise is going this way, you'll see that, oops, that's not clockwise, sorry, clockwise is this way. You'll see that you get the actual point 3, negative 4. Okay, that will create the new point C. And if I were to connect this together, yes, you get the right angle. And if I ask you to find the slope of AC, this would be then x sub 2, y sub 2, and then x sub 1, y sub 1 is still 0, so negative 4 minus 0, and then 3 minus 0, so that's negative 4 over 3. And so my question is, how do these numbers compare with each other? Notice then that, yeah, compare the slopes of AB. What conclusion can you make? Can you see that the numbers are flipped? And there's also a negative in front. So really the idea is this. Perpendicular slopes have slopes that are negative of each other, but not just negative. When we flip it, the key word is reciprocal. So that's the idea of a flip. Okay? So a negative reciprocal. Or sometimes they'll use this idea. Notice 3/4 times negative 4/3 equals to -1. Or sometimes some textbooks will say they multiply, the two slopes multiply to -1. I prefer the negative reciprocal idea, but once again, some textbooks say perpendicular lines have slopes that multiply to -1. Alright, knowing that, let's see if we can apply some of these things now. So, as a quick summary, okay, slopes once again represent the steepness of a line. And for parallel line segments, if they are parallel, the slopes are the same. Or equal, I guess you could say. Equal. But for perpendicular line segments, if there are two of them that are perpendicular, their slopes are what I call negative reciprocal. Or, once again, the two slopes multiply to -1. Okay. So if I have this question, I've got two line segments, MN and PQ. The question is there parallel? Are they parallel or are they perpendicular? So what do I need to do? I probably need to find the slope first. Yeah, so I'll find the slope of MN, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 4 over -3. That's what I got here. Okay, so that's the slope of MN. How about the slope of PQ then? -6 minus -2 all over -1 minus 2. That's -4 over -3. That equals to +4 over 3. So notice that the slopes here are not the same, so they're not parallel. And they're actually not negative reciprocal either. So this one is neither parallel nor perpendicular. Trick question. It's neither of these. Okay. Alright. I know, tricky. Okay, so now let's do a more maybe standard question where I say now find the slope of a line that is perpendicular to the line passing through S and T. Once again, you need to pretty much find the slope of ST first. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. I hope you're not tired of the song yet. Notice this simplifies to the fraction 9 over 7, so that is the actual slope of ST. But to figure out the perpendicular slope, remember perpendicular slopes, negative reciprocal, so negative and then flip it. There you go. Alright, this is the negative reciprocal of 9/7. Okay? Good. Example number 3. Find... Oh, the points P, Q, R are given. Find the coordinates of point T on the y-axis so that the segment RT is parallel to PQ. Okay, so I'm going to actually label and draw this first. 2, -5. That's there. -2, 1. That's here. So here is my line PQ. And then R is 3, -1. Right here. And then T is a coordinate on the y-axis. I don't really know where it is. I'm just trying to guess if they are parallel. Probably something like this, perhaps. Okay, question mark, question mark, question mark. The key thing to note is these are supposed to be parallel. And so the question is, how do I actually find out the coordinates of point T? Well, because it's on the y-axis, I know it's going to be 0, comma, y, right? The x value is always 0 when you have a point on the y-axis. Okay. The key word here is parallel, so what do we know about the slopes? That's right, they are the same. So let us calculate the slope of PQ, and then let us also calculate the slope of RT, and then let's make them the same. That's it. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, 6 over negative 4. That simplifies to negative 3 over 2. Now between r and t, remember the t, the coordinate is 0, comma y, so slope equals y sub 1, sorry, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, here we go, y plus 1 over negative 3. Okay. So, because they are parallel, since PQ is parallel to RT, then we know that the slopes must be the same. And now if I were to solve this, I can solve by cross multiplying. Negative 3 times negative 3 is 9. 2 bracket y plus 1. We'll distribute 2y plus 2 equals to 9. We'll subtract 2. We'll divide by 2, so 7 over 2 or 3.5. Nice. So therefore point T must be the coordinate 0, comma 3.5. And that looks pretty accurate as to what I was drawing. Yeah, right there, about halfway between 3 and 4. Okay? Good. Ah, interesting. Number 4. I'm going to let you think about this one. I've given you a grid here. You can also graph. This says a line segment has endpoints A, which is negative 2, comma 3. And also B, which is 8, comma negative 3. So there's this line. It says determine the coordinates of point C so that the segment AC is perpendicular to AB. So I'm going to take A, and I'm going to make my right angle there. And the question is, what could point C be so that I have a perpendicular? Now, is there more than one answer for part C? Yeah, I think C could be here, 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 here. It could be anywhere along this line. So yeah, there's more than one point. I'll say you bet. Okay, but you have to try to figure out one of them yourself. So just give me one answer here. I think what we need to do first of all, once again, is find the slope of AB. And to do that, slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. I have here the slope is negative 3/5, which makes total sense because if I look at this, I can say, hey, going down 3 units for every 5 I run to the right. Right? So if that's the slope of AB, the perpendicular slope will be the negative of negative, which is positive, and then the flip would be 5 over 3. Now remember, this is the idea of rise over run. So now if I look at the green line, I just need to go 5 up from point A. 1, 2, 3, 4, 5, and 3 over. Perfect. So here could be one possible answer for C. So I'll say one possible answer is 1, comma 8. Okay. All right. Now, is that the only answer? No, I could have went the other way. I could have, instead of rising 5, I could have went down 5, and then to the left 4. 1, 2, 3, 4, 5. 1, 2, 3 as well, and give me this point too, negative 5, comma, negative 2. So like I said, there are many different options, but these are just nice, easy whole numbers, so I'm going to quote that as my answer. Now for part B, like I said, there's more than one answer for point C, but if I had a restriction that point C had to be on the x-axis, what would the answer be? So when I put things on the x-axis, my coordinate is, of course, x comma 0. The y value is 0. So now the slope of AC has to be, well, A is this coordinate, so I'll call that x1, y1. C is now x2, y2. So 0 minus 3 all over x sub 2, which is x minus negative 2. So here we have negative 3 over x plus 2. This is the slope of the line AC. And what is the slope of the line AC supposed to equal to? Look back at part A. That's right, 5/3. So really, I want you to make this equal to 5/3. We'll cross multiply once again and solve. So negative 9 equals to 5 bracket x plus 2. Go ahead and expand, subtract, and divide. Negative 19 over 5, which is about what? About 4? That looks pretty good here, right? Pretty close. So the coordinate is negative 19 over 5, comma 0. There you go. Okay. Last example here. Ooh, long one. I have a line segment. CD. Okay. Point P is such that PC is parallel to CD. Okay, now really I shouldn't be using the word parallel because they actually share the same point. So maybe I want you to cross this out. I'm going to show you a new term called collinear. Okay, and I'll say on the side here, collinear has a point that is shared on both line segments. Right, so the two line segments here share point C. Okay, so key thing, collinear, parallel, same slope. Okay, that's the key idea. Same slope. So find the coordinates of P if P is on the part I is the y-axis, so that's 0, comma y. And part 2, x-axis, that means x, comma 0. Okay. So I'll do part A sub I. I'm thinking, I need slope, so I better find the slope of CD. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. I got 3 over 2. Now I should calculate the slope of PC as well. If PC, here is my P coordinate, here is my C. It doesn't matter which one you want to use as y sub 2 and all that. I could use this one as x sub 1, y sub 1, or x sub 2, y sub 2. So 2 minus y over, 6 minus 0, that's now 2 minus y over 6. Ultimately here, collinear, parallel, same slope. So let's make the two slopes equal. 3 over 2 equals to 2 minus y over 6. And once again, cross multiply to solve. (18). 4 minus 2y. 14. Negative 7. So the coordinate is 0, comma, negative 7. Okay? Can I get you to please try I? Same kind of process. So I think you can do it. So press pause, do it, Then come back to double check your answer with me, please. Do it now. So I'm going to call this x1, y1 now. This is still x2, y2, so 2 minus 0, 6 minus x. And now I want to make it to the same slope, so 3/2, right? The slope of CD equals to 2 over 6 minus x. Cross multiply and solve. There you go, 14 over 3, comma 0. Done. Okay. Got that? You should be happy. Now, let's see if you can get part B. Now I'm saying that, hey, those 2 points are perpendicular. Oh, perpendicular to CD. What do you know about the slope then? Yeah, they're supposed to be negative reciprocal. So above, we found out the slope of CD was 3/2, so the perpendicular slope is now not 3/2, but negative 2/3, right? And so now the slope of PC has to be equal to negative 2/3. Well, we found the slope of PC already, so let's just go ahead and use it. 2 minus y over 6. Now we want to make it equal to negative 2/3 because this is the perpendicular slope. We'll then cross multiply again, so negative 12, 3 bracket 2 minus y, and then we can solve. Negative 18 equals negative 3y, y equals to 6. So now the new coordinate actually is 0, 6 if I want it to be perpendicular. Alright? And I think you can try the next one. Don't need me, but if you do, here we go. Once again, the slope is negative 2/3. This time I'm trying to make it equal to this expression. Same question, right? 2 over 6 minus x. Cross multiplying here. Negative 12 plus 2x equals to 6. 2x equals to 18. X equals to 9. So the coordinate here would be 9, 0. And those would be the coordinates if I asked you that PC was perpendicular to CD. Okay? Last one though. Whoa. No longer is this point on the y-axis or on the x-axis. This point now lies on the line y equals to x. So where are all the points on the line of y equals to x? Well, the points of the line y equals x are here. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, negative 1, negative 2, all those things. Whoops, don't know what happened. So how do I describe points on this line? The x value is x, sure. What's the y value? Well, it's equal to x, so I'm just going to use x comma x to represent a point on the line y equals to x. So now if I'm asking you for the slope of PC, remember here's the p value, and what was c again? C was, what was it again? C 6, 2. So 6, 2. How about c somewhere over here? 6, 2. I'm asking you if I want it to be perpendicular, what must that value be? So I'm thinking, I want to make a perpendicular line to here. The value I'm looking at is probably right here. That is probably point P. How do I figure that out though? Well, once again, what's the slope of PC? If I call this x sub 2, y sub 2, x sub 1, y sub 1, slope equals y sub 2 minus y sub 1. all over x sub 2 minus x sub 1. There's our expression for the slope of PC. And this is supposed to equal to, that's right, 2/3, but negative, right, because it's perpendicular. So therefore x minus 2 over x minus 6 equals to negative 2/3. We'll cross multiply, so 3 bracket x minus 2, negative 2 bracket x minus 6 close bracket, and now we can just solve for x. Here we go. 3x minus 6, negative 2x plus 12, 5x equals to 18. This is all that algebra you did in chapter 6 of math 9. And x equals to 18 over 5. So the coordinate of the point P in this case, if we're looking at a point on the line y equals to x, is actually 18 over 5, comma 18 over 5. And that's it for this one. Okay? Understanding these two concepts with slope, very important. The next lesson is probably the most difficult and intense of them all. So when you get your head on straight and when you're fresh and when you can learn clearly, then come back and watch that video there too. And until then, we'll see you soon.